less than 3, multiplying radicals. That's the standard we're trying to accomplish. We'll be able to multiply radicals after this. Obviously, I think when you're multiplying things, your numbers inside are obviously going to get what? Thanks, buddy. They're going to get bigger, right? Which means we're going to have to do what? Which we've been practicing. Simplifying, right? So as you multiply, you're going to keep getting bigger values, so then we're going to have to break those back down. Okay? Sometimes it's easier to break them down first, if they can, and then multiply, so you have less to do. Okay? And we'll talk about that. But anyways, a little forecasting. Use calculator to determine whether the following statements are true or false. You guys don't do that right now. I'll just kind of help you. We'll go through these, okay? Root 2 times root 3 equals root 6. We already stated that is possible, right? Root 2 times root 3 is root 6. So this one is a true. Okay, so when we look at these ones, 2 times negative 4 is negative 8. Root 5 times root 3 is root 15. That is true. We're going to learn that today. That's I kind of say multiply like terms. The coefficients get hit and the radicals get hit. Okay? This one's a no because different indexes. Root 2 and root 3. Okay? 2 times 3 is 6. 10 times 7 is 70. Okay? That one can be done. It's a cube. Cube root, since they're both cube roots. Okay? And the last one you can automatically just see they have different what? Indexes, so that one's false. Okay? Or no, I guess I use no. True, no. True, false. Use false if you want. Okay, so again, based on that, write the rules. Okay, so multiply radicans and coefficients if indexes match. So if your indexes are good, you multiply the radicans by the radicans, the coefficients by the coefficients. Okay? And you go from there. You see right below they have their definition too if you want to use that. Okay? Onward here, I'll just kind of preface. What's that? Oh, sorry, you guys good? So here's the one they have here. Multiply numerical coefficients by numerical coefficients, radicand by radicand, and simplify. That's our steps to doing it. So here's one. And I like this one for A, so I really want you guys to pay attention to this. I don't know what it is, and maybe I need to figure out a different way to explain it, but a lot of people miss this one. I don't know if it's a mind trick. I don't know what they see. But what's weird about this, or what's going to happen? Just going to be the answer of 8. This one's answer is 8. Here's 2 reasons why. When you're writing something x squared, right? X squared means x times x, right? So that's technically root 8 squared, isn't it? Cool, that's 8, right? Also, if you want to do it the long way, by definition of multiplying radicals, what's 8 times 8? Well, we know square root 64 is also 8. Okay? So what I'm trying to show you is that when you do same radicand times same radicand, it's just gone. It's just 8. If I do a root 11 times root 11, it's 11. Okay? A lot of people just, for whatever reason, I get root 8 a lot. They say it's still root 8. No more root 8. Doesn't make sense, right? Because since you're just erasing something. Okay? So this one, I'll do these ones to get you guys started here. 4 times 3, 12. Root 5 times root 6, root 30. Simplify where possible. 30 actually doesn't break down because 4 doesn't go into it, 9 doesn't, and then you're too big. 16 is too big. Okay? So 30 doesn't break down. Okay, this one. This is just making you follow your rules. Don't freak out because the x and y. 4 times 3, 12, no problem. X times y is just xy. It's not a magic new number. Okay, it's just xy. Just show that you multiplied them. That's all you have to do. And the last one there, negative 2 times 5, negative 10. I know these will break down because 12 and 8 break down, but we'll multiply it first. That's 96, I believe. Mental math's a little slow at the beginning of the year, but 96. What goes into 96? We know 4 does. 16 does, right? Right. Yeah, for me, I'd probably go 4 times 2, 4 times 3, because the 4s would come out, what's 4 times 4? 16, right? Look, 2 times 3 is 6, so we're kind of getting the same thing. Yeah, if you like to work with smaller numbers, that's what I would do. Yep. Okay, so 16 comes out to 4. We're done. Negative 40 root 6. All right. Good. We only got 1 page and a little bit left. Okay, so should be a quick day. All right, so let's go ahead. I'm going to do the first one. Actually, no, here what I'll do. I'm going to do B. I'll have you guys do A and C. Okay, and then we'll talk about D together. Sound good? So here we go. B. So what do you think you do? We're talking about B first. Yep, distributive property. Now, Nolan and Parker, like if you want to break the 45 down, go for it. Want to break 20 down? Go for it. Okay? You can do that first and then rewrite it. You guys understand? Why? Because 45, I know 9 goes into that. 20, I know 4 goes into that. Okay? If you don't know, that's fine. You can just go ahead and multiply first. Do you have to? Nope. We can just go ahead and do the operation, Emily, so I'll do that first here. Watch. 2 times 3, 6. 5 times 45, so this is what you're going to have, though. 5 times 45 is going to be pretty big. That's 225, I believe. Okay? 2 times 8, negative 16. 5 times 5, oh, we like that. I'm going to write that as a 5, right? Right? Root 5 times root 5. Okay? 2 times 3, 6. Root 5 times 20, 100. So this one actually worked out because why? Don't forget about 225 because it's a what? It's a perfect square, and so is 100. So these ones actually all go away. Root 225 is 15. Root 100 is your 10. And so we actually don't have any radicals, which is nice. Yeah. That's really tricky how they did that. See that? 615, 165. Really mess you up if you don't, little dyslexic moment there. It looks like the same. All right, 6 times 15, 90. 16 times 5, 80. 6 times 10, 60. So this one's answer is 70 for part B. Go ahead, you can ask a question. I'm going to pause the video, though. Try A and C, please. All right, so let's look at the first one here. We should get root 50, so 2 root 50, because I multiply it into the 10. And that's 25 times 2. That comes out as a 5, and now we multiply. So 10 root 2. Cool. Root 5 times root 5 minus 5, we're done. 10 root 2 minus 5 for the first one. Okay. Then for C, we can put the 2 in. Put the negative root 2 in. Make sure the negative hits both. That's what I said some of you guys messed up on. 2 root 3 minus 2 root 5. Negative root 12 minus root 20. And the 12 and 20, you can see that they need a little bit of work. So this is 4 times 3, 4 times 5. Comes out as a 2, comes out as a 2. So you see you have 2 root 3 minus 2 root 5 minus 2 root 3 minus 2 root 5. So these guys cancel, and you're left with negative 4 root 5. A lot of you guys got that, so that was good. Okay. So if I do distributing, if I go too fast, I'm sorry, but 2 hits there, 2 hits there. Just rewrote it. Root 2 times 6, root 12, root 2 times 10, root 20, both with negative because they both were positive hit by a negative. We broke these down. 4 times 3 and 4 times 5. 4 comes out of 2. 2 root 3, 2 root 5. All right. So Eleanor got this right, so I checked that with his. Negative 4 root a times root a. What happens? Negative 4a. Okay. Negative 4 times negative 9. Positive 36. What goes inside? A, B. And that's, you can't do anything else. You don't know what A and B are, so you can't simplify anything, right? So that's as far as you can go. So the variable ones aren't really, actually, they're probably easier because they have to be stopped, right? So just keep that in mind. All right, we got example 3. Then we're talking about conjugate, and then we're done. All right. Pause it here. Some of you guys are still writing. Example 3. Okay, simplify the expression, the area of each shape. So there's obviously, we know that area, okay, area of a square or rectangle is length times width. They're making you multiply radicals. Just their way of making you multiply. So this one, we're going to multiply. Those are two binomials, though. So what do we have to do with those? I love the little thingy. Yeah, you got a FOIL, right? First, outside, inside, last. Okay. So we got to go 7 times 4, 28. 7 times root 6. So we line these up, and we're multiplying them because it wants the area. Yeah, and we're going to combine like terms at the end. Negative root 6 times 4 is a negative 4 root 6. And then we like negative root 6 times positive root 6 is a negative 6. Do we see that? I'll wait. Yeah, we're at the end of the lesson. People are getting worn down. So you see at the end there, it's a root 6 times root 6. It's just a positive and a negative, so it's a negative 6. Yeah. And so you can see we have these to combine and then these to combine to finish. 28 minus 6, 22. 7 root 6 minus 4 root 6, 3 root 6. And now we're done. That signifies the area. Okay? That's the area. So what could make our life easier on B? Good. But when you're squaring them, unfortunately, Parker, and you can correct me if I'm wrong, Parker, but did you think we could do this? Can't do that. Because it's a binomial, so we have to still FOIL. Okay, that's awesome that he said that. People do that all the time. They think whenever you have a square there, done. Whenever it's two terms, you have to FOIL out. There's a middle you're forgetting. Okay, so, but the other thing I was pointing out is, what do we know about 18 and 27, though? Yeah, they can be simplified. We don't have to do as much work. So I'm going to go ahead and just simplify these real quick. This is 9 times 2. This is 9 times 3. So instead of using 2 root 18, I'm going to use 2 times 3, 6 root 3, or 2, sorry, minus 3 root 3. I just broke down the 18 and the 27. 3 times the 2, 6. The 2 is left. Nothing out there, so it's a 3. The 3 is left. Now we square this. So to square it, we're just going to write it twice. All right, I'm seeing a lot of confused faces. So let's pause it. Let's see. Okay, yeah, so we're squaring it because it's a square. The sides are the same, so we write them the same and multiply them. So as Parker just said, it is. It's 6 times 6, which is 36. Root 2 times root 2 is 2. And then we go 6 times negative 3 is negative 18. Root 2 times root 3 is root 6. What's that? This one? They're the same. So these two things are exactly the same because they're the same side. Right here. Yeah, see, we made this 9. We pulled the 9 out. Yeah. Okay. Right here, negative 18. Again, look, that's nice. Comes with a root 6. So we're familiar with that. And the end, negative 3 times negative 3 is positive 9, and then a 3, because it's root 3 times root 3. Now we just got to simplify, and we'll be done with this one. 72 plus 27, 99. Yep, 72 is 36 times 2. 9 times 3 is 27 for 99. And then these two, negative 18 root 6, negative 18 root 6 is negative 36 root 6. And that's the simplified answer for the area. Get that going. Yeah. I don't know. Cheers. Yeah. Go. No. Does anybody know what a conjugate is? We're talking about multiplying conjugates next. Okay.
Pair of binomials.
Right. One's positive, one's negative. Now, you're going to see why we like conjugates for radicals. Okay? Because we're going to learn how to rationalize. Okay? When you rationalize things, we don't want radicals places. For example, we don't want radicals on the denominator sometimes. We want to keep the denominators above. Dividing radicals, that's why it's 2 days. So, but anyway, these are conjugates. And I want to show you what happens. We have 1, 2, 3, 4 radicals. Watch what happens when we FOIL this. What's root 5 times root 5? 5. Okay? What's root 5 times root 2? Root 10, right? Negative root 2 times root 5. Negative root 2 times root 2. Cool. 3. Right. Conjugate's purpose is to eliminate radicals. So you can use a conjugate to your advantages to get rid of radicals at times. Okay? It is 5 minus 2, right? 3. No, it's negative times a positive is a minus. So there's not a minus there already. Yeah. Okay, this one, 4 times 7, negative 16 root 7, positive 16 root 7, which we expect, and then negative 64. So the catch is, guys, once you guys are getting good at these, I don't need to see the middle anymore. You guys know what's happening in the middle of the conjugate. Okay, so this is gone. 4 times 7 is 28, minus 64. I believe that's the 36. Yeah, negative 36. Okay, so negative 36 is part 2's answer. So like, what do we notice? We just talked about it. We notice the middle cancels with conjugates. Okay, the radicals go away with conjugates. Okay, conjugates, and conjugates are anything that's opposite sign of each other. So it has to have the same terms, okay? Has to have the same terms. So you can't do root 5 minus root 2 and then 2 minus root 5. Same, right. It has to be the same order. You just simply change the plus minus. And people think, well, why is that negative root 5? That's not definition of conjugate. It's just what connects them, okay? All right, so let's look at a couple examples of that, and then we'll be done. Okay, here we go. Write the conjugate of each, then multiply. So go ahead and try that. You guys write the conjugates. I'll give you about a minute here. Just write the conjugate of these 3. So, the conjugates. Lucas, what do you got for the first one? Okay, that's the conjugate. Good, I'll leave it there so we can multiply it in a second. Britton, what do you got for a B? Minus root 2, good. And I like that he kept, now he didn't change that. That's how Emily was asking. Change everything. Nope, just the connecting term. Okay? So you leave that outside the same. The reason being is because what's a negative times a negative? Positive. We want those to match up. Okay? And then the last one, Hunter, you want to do the last one?
5 root x minus root 1.
Okay. You mean plus?
Well,
Because it's got to be the... Okay. It's got to be the opposite of what's there. Okay? All right, so let's go ahead and multiply these. Let's see what we get. 4 times 4, we got 16. We got 6. I'm going to skip the middle. Is that okay? Okay. 3 times negative 3, minus 9. 16 times 6 is 96. Minus 9 is 87. So we got 87. Okay, part B. Negative 3 times negative 3 is 9 with an 11. Root just minus 2. So we 97, good. Last one's going to have variables in the answers, that's okay. 25x minus y. That's all you can do, right? 5 times 5, 25. Root x times root x, x. Negative root y times root y is just y. Okay, that's all for lesson 3.